Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're looking at a question from one of the past papers, and it's a question that has two balls that are thrown at the same time. And they don't usually ask this in a hurry, but nothing stops them from asking it as a level 3 or level 4 question. All right, so let's look at this question. Ball A is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as a reference point. All right, so we're using the ground as a reference point. The ball A is thrown upwards at a velocity of 16 meters per second. All right, and ball B is dropped at 9 meters per second. Calculate the time taken by ball A to reach the ground. Calculate the time taken by ball A to reach the ground. So write down 3.1. Right, let's write down our answers. First, we need our data. What data do we have? First, you must choose a direction as positive. Okay, so you take your direction as positive. We usually take down as positive, isn't it? What else do we have? All right, we take down as positive. Then we know that acceleration is always positive 9.8 meters per second squared because we're taking down as positive. And what else do we know? Anything else? What's the final velocity of the ball? Ball A is projected upwards at 16 meters per second. When it reaches the maximum height, wherever it goes, the velocity will be 0. And then when it comes down, the velocity again will be 16 meters per second downwards. All right. So it's 16 meters per second upwards, maximum height 0, and then 16 meters per second at its lowest point. So we got a few things that we can do. We can do the calculation using the whole motion, or we can use up only and times it by 2. All right, so I took the whole motion. So V initial is minus 16, A is 9.8, and V final is 16. All right, and if you work that out, you got VF is equals to VI plus A delta T. Your V final is 16. Your V initial is minus 16 because you must take down as positive. I think we should write here. All right, we took down as positive. And then put your data as well, nah? Write your data, don't forget. Don't be too clever like me, then you make mistakes. All right, 3.2. So the first answer is 3.27 seconds. 3.2, sketch a velocity time graph for ball A. Right, so we must do ball A, a velocity time graph. So you put velocity on the y-axis and time on the x-axis. All right, so do a sketch graph. We'll just put in the main points because you're not doing it very accurately. So what's your initial velocity of the ball? If you're taking down as positive, what's your initial velocity? Minus 16. Right, we know minus 16. What else do we know? We know minus 16 as your initial velocity. We know the acceleration is 9.8. We know the time of the whole motion, which is 3.27 seconds. Right, so then the final velocity will be plus 16. So what type of a graph will we get there? And what we know is we'll get a straight line graph, but depending on how you do it. If you look at this graph here, the initial velocity is actually, if you take up as positive, this is the graph that we have, right? If we draw our graph, let's draw it quickly. Let's see if I can draw it. Shapes. Hopefully we'll be able to draw it quickly. Here's our graph. All right, that's our graph. We're drawing under the axis, and then drawing the other axis. And our initial velocity is minus 16. All right, and our final velocity is 16, positive 16. So our graph will be the other way. It will start here, it will go there at half the time, 1.63, and then it will carry on straight and our velocity here will be 16, and your time will be 3,26 seconds. All right, so let's just put in some values there just to make it correct in terms of our frame of reference. We're taking down as positive. Okay, so let's just see. Okay, it's gonna be.
When wasn't it 3,26 be 3,27?
Yeah, 3,27. Oops, how come it made it 3,26? So it will be 3,27, right? So I'm just going, to draw is going to take me a while. So I'm just going to put it here. All right, like that. And I'm going to just put it there. It depends on the frame of reference you take, right? And we know that this value must be 3,27. So let me just put it as 3,27. There must have been a rounding of issue there. 3,27, correct. It's good, you're awake. I'm sleeping. Let's just see, let's see this up. Right, will be 3,27. Doesn't look nice, but I'm leaving it there like that. Right, so it's a blue line, and we took our initial velocity is minus 16, final velocity as 16, 1,63 is at maximum height, 3,27 is where it's supposed to be for us, as is your time, all right, and velocity in meters per second and time in seconds. So those are the main issues that main points that we'll look at for giving you marks as to your understanding, right? Then the next question is 3.2 is done. Did we say initial velocity of the ball? Yes. Did we take the time taken to reach the highest motion? Yes, right. And then did we take the time to return to the ground? Yes. Did we put it down? Let's just have a look. All right, let's just have a look. We got it. All right, we've got the values that are given. Very important. Then the last question is the challenge that I said I will want to highlight today is if there's two balls thrown, right? 3.3. This is 3.3. I think I copied it. I forgot to copy the number there, right? So this is 3.3 now. Oh, yes, it's at the bottom. Calculate the 1 second after ball A is projected upwards. 1 second after ball A is projected upwards. A second ball B is thrown vertically downwards. So B is thrown vertically downwards at 9 meters per second from a balcony 30 meters high. So there we go, now 30 meters high above the ground. Refer to the refer to the diagram below, right? And the question is, calculate how high above the ground ball A will be at the instant the two balls pass each other. Okay, so now I look at the sum and I said, okay, we've got two balls. We don't have enough information for each of the objects. So how do you do the sum? All right, so what I want you to do is write down the data for each of the sums. Write down the data that we've got. Write ball A, all right. Choose data that you're going to say for ball A. Write on ball B, write on the data for ball B, all right. And let's see what we get, what we got. All right, so if you look at it, that's the data that we have, right? For ball B, ball A, you're taking ball A is up, ball B is down, your V initial is minus 16, for ball A is 9,8, that's all. And then for ball B, we got V initial as 9, your V final is 9,8, and your time, it's thrown up after 1 second, right? So this is important. Write this down that if you write ball A, its time is T seconds, then ball B, the time will be T minus 1. So if this is 10 seconds, this will be 9 seconds. So that's what we're saying because you threw it up 1 second later. Write it like that, right? Delta Y we don't have, VF we don't have for each one. All right. So now, once we've got this down, let's write down equations in terms of delta Y. Let's write this equation down. Delta Y is equal to VI delta T plus half A delta T squared. And taking the information from the data that we have, we took down as positive, fill in the values, right? So if you look at ball A, delta Y is equal to VI delta T plus half A delta T squared. What do we know? What do we know? Write down the values. Delta Y we don't have. V initial will be minus 16. T will be T. half is half, a is 9,8, t squared will be t squared. All right, and then we can stop there. We can't do anything else for ball A. Now let's do the same thing for ball B. All right. Right, so write down some values there. Let's see what we get. Minus 16t plus 4,9t squared. Right, that will be the ball A. For ball A, that's all we've got. For ball B, VI is 9, T is T minus 1, plus half is half. A is 9,8 because 9,8 is positive downwards, and T squared will be T minus 1 squared. Then let's continue with the values for Y, distance of B. Carry on 90 minus 9 plus 4,9 T minus 1 squared. Right, then multiply the quadratic there out. If you multiply the quadratic there out, it's 90 minus 9 plus 4,9 T squared minus 2T plus 1. And then if you multiply that out further, we can say 90 minus 9 plus 4,9t squared minus 9,8t plus 4,9. All right. And then if you take that even further, get rid of the minus 9 and 4,9 can be added. And then 90 can be added with minus 9,8t. Then what do we get? So we get 0,8t minus 4,1 plus 4,9t squared. All right, so that's what we've got. We can't go on further from there. But what do we know? This is what we've got for the two equations, right? Ball A and ball B. And what did they tell us? They told us that ball A and ball B, the second they pass each other, that means ball A, the distance that ball A moves and the distance that ball B moves, the distance of the two of them together will be 30 meters, right? So what can we say? We can say ball A and ball B together will be 30 meters. So we take these two to be minus A plus B will equal to 30, correct? So we can say minus y of A plus y of B is equals to 30, right? And if you do it, take minus y of A, take this amount, put it down, minus 16t plus 4,9t squared, and then put a minus outside that because it's minus 1 YA. All right, minus YA will be minus, and then minus 16t plus 490 squared. That will be minus YA, right? And YB will be plus minus 0,8t minus 4,1 plus 4,9t squared is equals to 30. And then we do our maths for this. The minus will be multiplied inside there. We'll get 16t. And then if we calculate the whole thing there with everything and take the common factors, we get 16t minus 0,8t minus 4,1 is equals to 30. What answer did you get? Can we get one answer from somebody? What is t equal to? Somebody? Respond to me.
I got T is 2,24
Good.
seconds.
Yes, 2,24. Don't forget the S, right? Now we know T is 2,24, but what's the question? Calculate how high above the ground is ball A. So we have to work out ball A, right? So if we have to work out ball A, we got T now as 2,24 seconds. We can substitute, we want to know how high is ball Y. So we can substitute it in the equation. Delta YA is equals to VI delta T plus half A delta T squared. So substitute it. Let's see if we got T now. Can we work out what Y is?
William, how did you get minus YA plus YB is equal to 30?
Right, very good question, right? If you look at this diagram here, All right. What do I know? I know that A and B together will move 30 meters, correct? A plus B is equal to 30. But now, if you're looking at displacement, we must choose a direction as positive. All right. So we took down as positive. So we can say the distance that minus y moves up plus the distance that b moves down is equals to 30 meters. So that's how we got minus ya plus yb is equals to 30, because you're adding the two according to displacement.
Okay.
Okay.
Jazakallah.
So the distance that the two move A and B is 30. But because they're moving in opposite directions, one will have to be negative because the displacement of the two together will be 30. Okay, if we calculate, substitute t is equal to 2,24 in A, you get minus 16, and then t is 2,24 plus 4,9, then t is 2,24 squared, and you get 11,25 meters. Did you get the sum? I hope you got that answer. So that shows that the distance that the ball A moves will be 11,25 meters in the time when the two cross each other. Okay.